my project is bodybuilding. I chose this option because of the interesting use bodybuilding has in procedural animation in the game industry. My goal for the project were to change the topology of the body to a sphere so I attach legs at different angles. Parameterization of legs was the biggest part of the project, requiring legs at different areas and joints to rotate as well as the legs to rotate. A method for replacing the legs required some math as well. Evolve successful robots with any number of legs was one of the big goals of the project, so that anything could work. I thought of making a spider bot with 8 legs. Spider bot. Ah! The question. Does the quadruped evolve to move further than a hexapod for a fixed computational budget? I chose a hexapod to be my variant of a quadrupod because the increased complexity shows off the good representation of other robots with more legs. For the implementation of the bodybuilding, during my first level, I prioritized the number of legs to a constant num legs. Then, inside SourcePy, I rewrote generate body to replace the hard-coded creation of with a new method that prioritizes based on the number of legs you want between 1 and 4 for the first deliverable. In the second deliverable, I implemented a sphere and objectation in my version of PyroSim. I did this by going to the implementation of the cube and adding those features all the way up to the top. Now when I create an object, I can specify if I want a cube, or if I want a sphere, or if I want to rotate the object in any way. This is a huge for me as it specifies the rotation for the leg towards the body and the joint. The hardest part of the project for sure. For the third deliverable, I prioritize the sensor and motor creation, similarly to deliverable 1 for the legs. I thought that testing on many different types of legs from 1 leg to a few dozen. When it came to the variants for A/B testing, all I had to do was modify the number of legs constant. This would result in my prioritization work from my other deliverables. During the A/B testing, there were 2 best robots evolved, being shown here, from a population of 100 and generation 50. The results of the evolutionary training created robots that are much better than randomly generated robots. This can be seen for both the quadruped and the hexapod. In the graph here, the data collected for both robots were at the first point is shown to be a random robot for the mean fitness value on the graph. As the generations increase, the mean fitness value for both robots increase. This shows the evolutionary work of the robots. If I had another year to work on it, I would try to look at the inverse kinematics, try to add its technology to simulations.